you mean with time? Yeah, 10, I guess 11 with time. So, but double check, double check the however many dimensions. It's however many they needed to explain what they were trying to explain. Oh, it's not the case that we need to figure out more quantum stuff. It's the case that we need to have a theory that can explain the currently known quantum stuff. We know a lot of quantum stuff. For example, the spin properties of the different quantum particles, like fermions, electrons, different spin than bosons, as an example of quantum properties of different various particles, right? So it's not the case that we need to know more quantum. Sure, we can always know more quantum and more particle. And in fact, I mean, that is going on. But it's the case that we, whatever the grand unification theory is, has to be able to explain what we do currently know in quantum and particle. If it cannot, then it's not a broad enough or grand enough theory that can subsume the currently known stuff. Because if particle physics is giving us something that we experimentally observe and that explains our current reality, basically, like electron, it's a part of nature, it's part of our existence. Neutrinos, we see them from the sun, like it's not just that particle physics spewed out a bunch of particles that are not the reality. Particle physics has a bunch of particles that we see in nature, and those particles have different properties, different from each other. We discover new ones, they have new properties. That's what nature is showing us. Nature might not be showing us everything, but what nature has shown us must be subsumed and encapsulated by a grand unification theory. And if it cannot, then we won't accept it. It will be highly contested. I'm not saying that somebody should not work on a GUT, but it won't be easy because we do know a lot already that has to be explained by it. And yeah, the 11 dimensions are a part of that attempt. They came up with however many dimensions they need in order to explain some basic stuff. And because we can't do experiments with 11 dimensions because we only experience 4, string theory, in short, by the way, we will keep reading about it, but superstring theory, in short, cannot be proven. It cannot be experimentally demonstrated. And that's why it's still called superstring theory. There's no superstring experiment. And physics is an experimental science. You have to show things experimentally in order for it to be accepted as a science. And so, unfortunately for the superstring theorists, even though their theory might be more beautiful than particle physics, it remains a theory rather than an experimentally proven fact because we can't do experiments with 11 dimensions. I mean, not yet, anyway. We experience 4 dimensions, including time. It could be that we're limited. Part of the discussion is that we could be limited. We just don't experience these extra dimensions because we're limited. We just don't. It could be that we don't. But the fact remains that it's challenging. It's challenging for the theory. It's challenging for the field to accept it without proving it out. Okay? So at one point in the 1950s, physicists despaired of making sense of subatomic particles because new ones were being discovered all the time. Oppenheimer, in disgust, once said, "The Nobel Prize in Physics should be given to the physicist who does not discover a new particle this year." Because the particles were being discovered quite often. These subatomic particles were given so many strange Greek names that Enrico Fermi